In this video, we'll be taking a look at the new beta feature in Instana that provides an improved experience for creating and managing service level objectives. Service levels can make it easier for customers to define, track, and continuously improve targets for system performance. This helps ensure a consistent level of service reliability and that any service level agreements are maintained and met. It also helps define an acceptable level of downtime for an application or service, and improves visibility to help identify problems and take corrective action before they become critical. The SLO beta capability in Instana provides the ability to access SLOs with top-level navigation in Instana, manage SLOs for applications and websites, and visualize their performance with an enhanced dashboard. Additionally, the SLO beta framework provides the ability to configure smart alerts to send notifications on status or error budget consumption, and the ability to run diagnostic or corrective actions on an SLO alert condition. Now let's take a look at all of this in action. First, we can access the new service levels area via left-hand navigation on the home page. From here, we'll see a table of all of the SLOs with essential information such as SLO status and target, and error budget remaining with an associated Spark chart. We can filter this view based on tag or entity type. Additionally, we can edit, copy, or delete an SLO from this view. Next, let's walk through the process to create a new SLO. First, we'll select our entity for our SLO, which can be either an application or a website. In this case, we'll select an application. We can also refine the scope of calls that will be measured in our SLO, as well as the specific services or endpoints. In this case, we'll select all calls, services, and endpoints. Next, we'll select the blueprint or type of our SLO. We can choose from latency, how fast the calls in our application are responding, availability, how often our calls are failing, or custom, where we can define our own filters for what constitutes a good or bad event. There are also two ways we can aggregate data for our SLO. Time-based, where we'll aggregate calls or events over 1 minute with different types of aggregation. Or event-based, where we'll calculate over the sum of all the calls. In this case, we'll select latency and time-based with mean aggregation and a defined threshold of 500 milliseconds. This means that the average of all calls in a given minute must be faster than 500 milliseconds for it to be considered a good minute. Now we'll set the target for our SLO, which in this case is the percentage of good minutes we are striving for in our time period. Setting our target at 99%, this means that 1% of the minutes are allowed to be bad without violating our objective. With the 1 week SLO time length, that results in an error budget of 101 minutes. Our time period can be fixed or rolling and can be specified in either days or weeks. The start time can be configured as well. We'll finalize the creation of our SLO by providing a name and any tags we'd like to use. We can preview data based on historical information from the past 7 days and confirm this is a reasonable target for our application SLO. Since our SLO just started collecting data, let's look at an existing SLO to view the dashboard. Here we can see an overview of the SLO configuration details, including the application and scope, and the time window. We also see cards that reflect SLO status, error budget remaining, and overall application traffic. The indicator chart shows how the measured indicator, latency in this case, is performing relative to the specified threshold of 1 second. Note that the increase in latency seen in the chart corresponds to a decrease in error budget. We can highlight this area on all the charts and also zoom in to take a closer look at a specific time range. The new SLO dashboard provides additional flexibility with visualizing SLO performance over time. In this view, we have the selected time option specified, which indicates data on the charts is matching the time window specified in the Instana time picker. In this case, the associated SLO time window will be derived from the end date in the time picker. If we change the time picker to show data from a longer period of time, and the selection spans multiple SLO time windows, data from different SLO windows is color-coded and visualized on the charts accordingly. Alternatively, if we select the SLO time window option, only data from the matching SLO time window will be displayed. The matching window again will be derived from the end date of the Instana time picker. We also have the ability to define alerting conditions or smart alerts for our SLO. From our SLO, we can see any smart alerts already defined. Let's walk through the process to create a new SLO smart alert. I select my current SLO and can choose what trigger I'd like to be alerted on. I can choose from percentage of error budget consumed or when the SLO reaches a certain status. In this case, I'll specify that I'd like to be alerted when my SLO has consumed more than 75% of the error budget. Next, I can configure how long I'd like the condition to exist before raising an alert. In this case, I'd like to be alerted a little sooner. Additionally, I can configure a cooldown period for the condition to be resolved before closing the alert. I can also specify a notification channel. I'll specify that an email should be sent when this alert fires. Lastly, I can customize the alert title, as well as configure the alert level and mark that this alert should raise an incident in Instana. I see my newly created smart alert in the list of alerts on this SLO. Additionally, I can see a holistic view of smart alerts configured across all my SLOs. Now let's take a quick look at an SLO smart alert in action. My application has experienced an outage, and my SLO performance is beginning to drop. We can see a spike in the indicator chart where my latency is outside the threshold. This correlates to a drastic drop in error budget, as well as a decrease in overall system traffic. The alert we previously defined to notify us when we've depleted 75% of our error budget has fired, and is visible on the error budget chart. We can select the alert icon in the chart and see more details on the incident page in Instana, including summarization and related events. Next, since we've seen this problem before, we've already set up a policy with the automation framework to remediate this problem. In this case, we'll run an Ansible playbook via Ansible automation platform to scale up our Kubernetes deployment to fix this problem. This action is available directly from our incident or event page. After executing the action, we can see the job was successful and view the output from Ansible. Navigating back to our SLO, we can verify that our indicator has stabilized and we've addressed the issue before the error budget was fully depleted. This concludes the overview of the new SLO framework in Instana. Thank you for watching.